For yesterday's notes, we just had to take an expression like this and break it into smaller pieces. And the reason we did that was so that we can evaluate integrals like this, because as this one is, the way it's written, we can't do the antiderivative of this. If we tried u substitution, set the denominator equal to u, we wouldn't get to the du that we need, it wouldn't work. But if we take this and break it down into smaller rational expressions, we can take the antiderivative of each of those individually and get this to work. So that's what we're going to do. Starting off here, we're just going to do what we were doing yesterday. And then after we figure that out, take a few steps to integrate what we end up with. So we have 17x minus 3 over, we can factor this, we're going to have two binomials, one with 3x, one with x. And we end up with 3x minus 2 times x plus 1. And we get 3x squared plus 3x minus 2x minus 2. That works out here. So we end up on the right side with two rational expressions, one with a denominator of 3x minus 2 and one with a denominator of x plus 1. Since these are both linear denominators, our numerators have to be 1 degree less. They're just going to be constant. So we're just going to have a and b. So once we have that set up, we're going to multiply both sides by this denominator here. And that's going to cancel everything out on the left side in the denominator. And then over here, it's going to cancel out their denominators and leave a little bit on top. So we have 3x minus 2 times x plus 1. Distribute that to each of those. So the first one, the 3x minus 2's cancel out, and we get a times x plus 1. Second one, the x plus 1's cancel out, and we get b times 3x minus 2. So we can go ahead and distribute those. We get ax plus a plus 3bx minus 2b. So we're looking for common terms, like terms. We have a couple terms that have x in them, and then a couple terms that are just constants, no variables. So we end up with 17x minus 3 equals, well, the ones with the x's, we can factor that x out, and we get a plus 3b. And the constants, we never have to factor those, we'll just leave those at the end. But now we know that a plus 3b is going to have to equal 17, because these two x terms have to add up to this x term. And the a minus 2b has to add up to our constant. So that gives us two equations that we can set up. We have a plus 3b equals 17, and a minus 2b equals negative 3. So with this system, we want to cancel out one of these variables. A is probably the easiest. I'm going to multiply this bottom one by negative 1 on both sides. So I'm going to make it a negative a plus 2b positive 3. And then the a's, when we add the two equations, will cancel out. And we get 5b equals 20. So b is 4. Then we can figure out a by substituting that back into one of these equations. So a plus 3 times 4, 12, equals 17. So a is going to be 5. So this is what we did yesterday, and we can kind of take this expression in here and write it as 5 over 3x minus 2 plus 4 over x plus 1. Well, we can do the same thing here with the integral. Remember, with integration, we can split up addition. So this integral right here is going to be the same as the antiderivative of 5 over 3x minus 2 dx plus the antiderivative of 4 over x plus 1 dx. So now, splitting it up into those two smaller pieces, these are easier to do. We can use u substitution here. So I'm going to set the denominator, 3x minus 2, equal to u. Du then is going to be 3 dx, which means we have to multiply the inside by 3 and the outside by 1/3. We can also take this 5 and bring it out in front because we don't need that inside. So we end up with 5/3 times the antiderivative of 1 over u du, and that's an integral we can evaluate. Over here, we can bring this 4 out in front, and since this is not just a plain old x, we should really use u substitution also, although I'm going to use v since we already used u. So v is x plus 1, dv is just going to be 1 dx. So really not much changing here. We end up with 4 times the antiderivative of 1 over v dv. So what is the antiderivative of 1 over u du? Natural log of absolute value of u, right? So natural log of absolute value of 3x minus 2 plus 4 times, same thing over here, we get natural log of absolute value of v this time, so x plus 1 plus c.